So if order is not important, then ABC is equal to ABC. Order is not important. But I want you to note this because we shall soon get to permutation. In combination, order is not important. So it doesn't really matter how many ways I can write ABC. ABC is ABC. Okay. So combination, order is not important. That's why I want to make sure you know what order is not important is. Okay. Suppose I have 7 pairs of shoes and I want to take 3 at a time. And I want to take 3 at a time to go and donate to charity, no matter where charity. I know that the formula for combination I know that the formula for combination says n combination r is equal to n factorial all over r factorial into n minus r factorial. All right, so I will have 7 factorial, the number of shoes I have at a time, all over 3 factorial into 7 minus 3 factorial. So this is how I'm going to do it. And don't worry about doing it with your card, by hand. But anyway, I'm going to just show what it is. 7 times 8 and 6, 5, 4, 3, 2, 1. And then I'm going to do 3 factorial, which is 3 times 2 times 1. 7 minus 3 is 4 times 4 times 3 times 2 times 1. Times 2 times 1. All right, just if I cancel from here to here, I now have 3 and 2. 3 times 2 is 6, so this and this will go. Therefore, my 7 combination 3 will end up being 7 times 5, which is 35. So there are 35 different ways I can choose 3 shoes out of 7 and give to charity. 35 different ways. Okay, so let me do that with my calculator. So I am going to, with my calculator, turn it on. How do I answer a combination question? With my calculator. So I will put in n. What is n? The total, the sample space. Remember that sample space is the same as the count, the same as population. So here you're going to hear sample space a lot. So 7, you don't put combination there. Go to math, arrow to PRB. I hope you're doing it with your calculator. And then I want you to see that combination is number 3. 7 combination. What number? 3. Which means I can actually use my calculator to solve combination. I calculate, I can solve any problem in combination. Therefore, if I do it by hand, it's an easy question. I'll get the same answer anyway. So there are 35 different ways I can select 3 shoes out of 7 to go and donate. Counting principle number 3 is permutation. And then we shall do a combination of all 3 of them. Let's go to permutation. Somewhere our book has permutation. Please, I want you to read. There are so many things to read. Don't wait for your teacher to read it for you. See, we just did an example of combination. We don't really have time to read PowerPoints. So I'm just selecting the ones that are important. I'm selecting PowerPoints that are important because we don't have time to read all of them. Okay, so do what you can do whenever you have. There are things, if you already know something, then you have to scan it. You don't have to just read in between the line. It's the one that you don't know that you take time and research. Okay, so here is a question. Let's go to this. So see, practice by hand. You can practice it by hand. I hope you see, if you can practice it by hand, you see you already know it. So for combination 1 is 4 factorial over 1 factorial into 4 minus 1 factorial. Everybody look. Let me make sure I make this. Anytime you see 1 factorial, 1 factorial is equal to 1. Anytime you see 0 factorial, 0 factorial is equal to 1. Don't forget that 0 factorial is 1. Because you will have a question like this. 5 combination 2 divided by 0 factorial. For those who don't pay attention, they will say no solution, undefined. Do you see the question? It's always going to be there. Some surprise questions will be there. Sometimes in the homework, sometimes in your SCT or SAT exam, whatever it is, you just want to know that from today, especially when you get to calculus, from today that 0 factorial is 1. All right, okay. So I'm showing you this practice. So when you go home, you are the one that's going to do that. We don't have time to do this. So, but I have already done one of them. Is that clear? Okay, next, the last one we need is permutation. So let's see definition of permutation. So you see that they did a whole lot of explanations for you. Please read this. Please read it. All right. So there are so many applications, DNA. Now we go to permutation, the next counting principle. There are 3 counting principles. Counting principle number 1 is factorial. We'll explain that. Counting principle number 2 is combination. Order is not important. We come to number 3, permit. Is the difference between combination and permutation. Remember, in combination, we said, well, let's go to permutation. I wonder why this is frozen. Minutes. We gotta have this. Let's finish this. We're almost done, so I don't have to. All right, so we want to make sure we know. From the definition, we want to know the difference between combination and permutation. So this is permutation here, and I'm trying to pull this down, but it's trying not to pull down. Okay, well, make it smaller. Whatever I have to do for us to. All right. It's trying to get frozen, but now we can freeze. All right, I'll try that again. All right, try that again. That is looking for my permutation. Give me. All right, permutation right here. It's not right. I'm sorry, but this is not funny though. It's not funny though. Okay. Let me go here. Let me see if it's going to like it for me. Okay. All right. Hopefully this is going to work. Okay. Number of permutations of n distinct objects taken R at a time. The number of arrangements of R objects chosen from n objects. Okay, we want to know what is the most important thing. How do I know that a question is a computation question? That is the biggest problem. This is what students are going to, in fact, maybe at the end of the day, somebody's going to start asking this question. So let's read the definition. According to our book, the permutation is an ordered arrangement. Why? See, it is order. An ordered arrangement. Arrangement. In other words, order is important. In other words, order is important in permutation. This is the most important thing to stress in permutation. Because in combination, order was not important when we're talking about it. But in permutation, the definition says it is an ordered arrangement. Therefore, there must be order. Is that clear? So let's actually start talking about those ABC again. Let's get to ABC. Suppose I'm given 3 letters. Suppose I'm given 3 letters and I am told to write the letters ABC, where order is important. Do an ordered arrangement of ABC. I am going to do only 2 or 3 of them. The first one is ABC. Where this? The second one is A, C, B. The third one is B, A, C. The fourth one is, because I haven't even finished. A, B, C is a different order. A, C, B is a different order. B, A, C is a different order. See? And C, A, B is a different order, and so on. Wow. So how many of them can I even have? So just so you know that when you are talking about permutation, your answer is going to be large. When I was talking about combination of ABC, I had only one combination. Order is not important. But now I'm talking about permutation. It's an ordered arrangement. Order is very important. What am I saying? Why am I saying this? I'm shouting this. I'm sorry if I am, because students don't understand and they misunderstand the meaning of permutation and combination. And if you don't understand the meaning of the difference, if you don't understand the difference between combination and permutation, then you will never understand the question. You don't know what a question is a permutation. You don't want to know what is a combination. All right. If a question is a permutation question, that is something that's going to tell you that is order. Okay. If it is not permutation, if it's combination, something like human beings. Suppose I'm selecting a committee of 5 from a class of 30. I want you to know, first of all, can I even order Grace? Can Grace be number 1? Can Grace be number 1, number 2, number 3? No. So sometimes order doesn't make sense anyway. So another thing you need to know is that if it's a combination, sometimes order does not make sense. Because if I'm talking about human beings and I'm selecting a committee of 5, there is no way Grace can be number 1. No matter how partial, no matter how biased I am, I cannot put Grace as number 1 member of the committee. Grace is number 2 member of the committee. Oh, Grace, you're number 3 because I love you. You're a member of my class. You're a good student. Oh, Grace, you're number 4. Grace, you're number 5. You know what? Somebody's going to think, is that teacher, she crazy? But so sometimes when you're when your argument arrangement doesn't make sense, the arrangement does not make sense, this permutation, because there's no way we can just select one person to represent a committee of 5. Human beings are discrete. Human beings are discrete. They're accountable. And so anyway, so by the way, how can I even know uh, the number of permutations here? I can say 3 how many of them? 1, 2, 3. So I can say 3 factorial. So what is the 3 factorial number of ways? Why did I use 3? Why did I use 3? The sample space is 3. So 3 times 2 times 1. 3 times 2 is 6. So actually, there are 6 different ways I can arrange ABC. There are 6 different ways I can arrange ABC. 6 different ways I can arrange ABC. I already stopped at ABC, ACB, BAC. Because guess what? ABC is different from ACB because it's commutation. ACB is different from BAC because it's commutation. BAC is different from CAB is commutation. It's not the same in combination. I hope I cleared this, because actually this question is going to be about 3 or 4 in the test. Well, guess what? If you don't understand the meaning, the difference between combination and commutation, is really going to screw them up. All right. So, let's actually find a commutation question. All right. So let's answer a commutation question. Let's go to, suppose I'm told to, I was talking about having 7 shoes before and taking 3 at a time. But I want you to see, in this particular situation, if I do 7 permutation 3, well, guess what? It doesn't really make sense, because it means that I can give it to charity. I can give it back. It doesn't make sense. You don't do that in real life. Therefore, I cannot use permutation for that. Uh, Having 7 shoes and giving 3 to charity. It's not a permutation question, because I can't even give it to them and take it back. Order is order. It's not important there. All right. Anyway, so let's answer a question. By the way, permutation is n permutation r equal to n factorial all over n minus r factorial. So that is the formula. If I am told to find 7 permutation 5, then I got 7 factorial all over 7 minus 5 factorial. Right? 7 factorial is 7 times 6 times 4 and so on. And 7 minus 2 is 2 factorial. So I can just get my calculator. I don't really have to use my calculator to do that. So you can just, let's do it here. 7 factorial is 7 times. Actually, they did it for us here. So, and so you multiply the remainder after you cancel out. And then you have 2,520. Okay. Calculator to do factorial. Do that. Is this answer correct? Let's find out. I'm going to get my calculator. I know we don't have time, but we can finish this. So I'm going to put 7 permutation 5, where order is important. 7 permutation 5. So I go to 7, go to math, arrow to PRB. Permutation is number 2. And 5. So now I got 7 permutation 5 with my calculator. I hope you see why I'm doing this today. So that way you know how you have practice. You will practice with permutation. By the way, we need a combination and permutation for unit 3 because binomial distribution, which is in unit 3, starts with combination. So we must do this today. We're not going to wait for it to be done on the review day, so that you understand combination, so that you will be able to apply it to binomial distribution. All right, so when I hit enter, I see that my answer is 2,520. In other words, there are 2,520 different ways of selecting 5 out of 7. There are 2,520 different ways of selecting 5 out of 7 where it's important, where order is important. In other words, you can keep on working on it on the order. Last thing we're going to do, we have 2 minutes. Oh, we have 2 minutes to go, but last thing we're going to do, let me just give you this. Suppose you are given this word. There are some words that are, suppose you're given the word smoke. Oh, no, it's clearing you. I'm talking about clearing you segments. All right. There are some words like Mississippi. My last name is pretty good. All right, so there are some words you can be told to find the number of ways you can write it. I would like you to try your last name. I'm going to try my last name. My last name is Ezenekwe, Ezenekwe. Don't worry about pronouncing it. But if I'm told to find how many ways can I arrange this word Ezenekwe, where order is important. First thing I want to do is count the number of letters in my last name. 1, 2, 3, 4, 5, 6, 7, 8. So I will write 8 factorial, the sample space of the count, over. I will count every repetition. Did any letter repeat? Yes, he repeated 1, 2, 3, 4. Any letter that repeated, you have to divide by that factorial. If none of them repeats, just have 8 factorial. So now I can say 8 times 6, 7, 6, 5, 4 factorial, divided by 4 factorial. 4 factorial cancel 4 factorial. Therefore, there are 8 times 7 times 6 times 5 different ways of arranging my last name as Zeneco. So I'm going to tell you how many it is. So when you want to do your last name, you do that. 8 multiplied by 7. I'm doing my last name. You can do your last name next time. Times 5. 4 factorial is taken. So when I get my answer, we say a whopping 1,680 different number of ways I can arrange my last name. Okay, let me give you the one that comes out in the test. The one you may see, it wasn't in the, it's not even in the practice test, but it might come out in the test. In fact, it will be your homework. Mississippi. I don't know that. Maybe for tonight. So, first of all, let's spell the word Mississippi. 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 All right. In how many different can we arrange the word? This is in the test, or maybe in the homework. It wasn't test last year. I took it out because I don't like the way people failed it. Right? It doesn't really matter because I am saying it. I don't think I said it last. I don't think I went over it in class, so they really failed the pre-test. I took it off the test. They really failed the pre-test. So, okay. Anyway, So the most important thing you want to do is count all the, what is the sample space? So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. There are 11 different letters. Well, 11 letters, they might not be different. Divided by, is there any repetitions? Yes, I repeated how many times? 1, 2, 3, 4. I repeated 4 times. S repeated 4 times. P repeated 2